Thanks everybody for coming out tonight and for all the organizers for hosting. So I'm going to be talking about Scour, which is a fast personalized content feed built in Rust. So a little bit about me. I've been writing Rust since 2017. I have a blog where I write about Rust and other things at emschwartz.me, and I'm working full-time on Scour, and this is my first time presenting it, so I'm excited and a little nervous. So you guys you're all the first ones to see it. Thank you. Okay, can I get a quick show of hands? Who reads Hacker News? Okay, a lot of Hacker News readers. Who has submitted something to Hacker News? A little fewer. Did you tell everyone in your life to upvote it right at the same time, or has anyone been part of one of those rings? I hear the chuckles because everybody knows this is part of Hacker News, where if you submit something to Hacker News and you don't get everyone in your life to upvote it immediately, what happens is that it's immediately buried under a pile of new things being submitted. And this happens all the time. This was recorded earlier today for just like a sample of it. And this is just constantly going. So a little while ago, I had this hypothesis that there's probably a lot of really good stuff that gets submitted to Hacker News, but doesn't go anywhere because people don't do the social engineering to like make sure it gets off the newest page, and so it's probably just buried. So I had the thought, what I would really like is something that knows what I'm interested in, watches the Hacker News fire hose or other similar kinds of noisy feeds, subreddits, lobsters, like any kind of thing like that, blogs, etc., and then just finds posts matching my interests. So I built a little prototype, was immediately impressed with like, oh, wow, I'm finding really good stuff, and decided to try to make it a thing. So this is what the front page looks like. You can scan that QR code or go to scour.ing to try it out. It's free to use. Would love for you to use it and try it. But just to give you a little demo, sorry, the QR code went away. Little demo of what it looks like. So it's a pretty simple interface. This is my personal feed. It's got links. It's got the tags are actually based on topics that I've said that I'm interested in. So it says which ones are most related to that. You've got the discussion links, etc. So you can configure your interests, etc. You can subscribe to specific feeds or just scour everything that we've got. Right now, it's pulling from 2,654 sources, and it scoured almost 250,000 posts in the last month and more all the time. So this is basically what it looks like. And yeah, so put that together, and it works pretty well. One of my personal metrics for whether it works well is both like, do I look at this and find more things that I find interesting than just browsing the front page of Hacker News or Lobsters? Definitely yes. And then the other thing that's really fun is that I often click on something and then maybe I'll look at the discussion on Hacker News and find that it's one of these posts that has 1 point on Hacker News and is definitely getting buried under the pile of newest things, but I thought it was great. And so I'm like, oh, wow, this is awesome. I'm super happy to have found this. And unplanned this morning, a friend texted me this who uses Scour, and he said he just became the 5th person to star this new JavaScript state management library on GitHub for the first time since Stumble Upon days. I feel like I'm right on the pulse of things. Thanks, Scour. That was not planned, and I immediately responded, this is going in my talk later. But this is sort of the vibe. Another thing I'm quite proud of is that it's really fast. And just before I talk about why, talk a little bit about why does speed matter? And there's a lot of obvious things, but I really liked this quote from an article about SQLite. And he said, there's a magic number for application latency. Responses in 100 milliseconds or less feel instantaneous, and you can really like feel that when you click around and something feels very responsive. So I'm quite proud of that. And then another thing that I learned from the folks on the Tiger Beetle team is that performance unlocks new use cases, because if it's really, really fast, you can do things that if it were just a little slower, you'd maybe not want to do. For example, the same friend that found that post set Scour as his new tab page. So every time he opens a new tab, he sees Scour. And that's the type of thing that, like, you don't really want to like open a new tab and see a loading indicator or have it slow down your browser a lot. Another example that is more for me that fun than for you, but you sort of get the benefit of it, is that while building this, I had the question a lot of times, should I like pre-compute all of the rankings for posts and then show it? So that would be really fast. The downside of that is it's more annoying to tweak the ranking algorithm. Because it's really fast, the rankings are actually done on the fly, which means that I can have a bunch of hidden parameters and such to tweak the ranking algorithm and see what does my feed or what does your feed look like in two different versions if I apply small tweaks to it. So these are kinds of things that if you make it really fast, you get for free. So now I'm going to talk about how it's built and why it's fast. We're going to go through Rust, a quick detour into binary vector embeddings, which is a topic that I think is just so cool. Hope you will too. SQLite, and then the MASH stack, which is fun. Rust, it's great. That's really all I'm going to say about it. You're all here. Okay, binary vector embeddings. So what are embeddings? Embeddings are sort of related, but not just part of the whole like LLM kind of space. But what embeddings are, you have an embedding model, you take some text, you run it through the model, and you get a vector or a series of numbers out. Now, that's not super interesting, but what's really cool about embedding models is that they let you compute the distances between two different vectors, and that tells you the conceptual similarity between those pieces of text. And these models are built up over large corpuses, so they have some concepts of it's not looking for word similarities. It's like, oh, Rust is also a programming language. It's compiled, it's fast. Like, it sort of has a fuzzy understanding of all of that. And so you can look for similarities between those. Embeddings are super powerful. It's one of the things that I think is a little bit hidden by all the attention on specifically generative AI, but it's a really neat topic. Hugging Face has lots of models to choose from. You can compare the performance of closed models, open models, different tasks. They've got different numbers of parameters. There's all kinds of different stuff. I knew none of this before starting this project, but it's a neat space to learn about. So when I was picking one, I had a couple of different criteria. I wanted it to be open, an open weights model, because when you use one of these embedding models, this is basically your database index. And I didn't really like the idea of relying on someone's API necessarily to build my database index, or I wanted to be able to migrate off of different ones. I wanted a low memory footprint. I'm trying to run this kind of on the cheap, so I don't have to charge people a lot. And some of these models, you need many gigabytes of memory in order to run them. I wanted something that's a little cheaper. There's different tasks that they're ranked on. The one I cared about is retrieval. And then I also wanted a reasonably small dimension. We'll come back to that in just a second. Nice to have multilingual performance and long context. So the embedding dimension is how big the vectors are that you get out of it. So they commonly range anywhere from 512 to 4096. And each of those represents normally float 32. And so the memory footprint is that dimension times 4 bytes. And so they range from 2 to 16 kilobytes normally. Some models support this neat thing called Matryoshka embeddings, which is named after the Russian dolls. And what they allow you to do is truncate the output of the embedding and retain quite a high degree of accuracy, which is really weird and wild and cool. But I think the way they kind of work is when they're training it, they sort of include this as a loss function. And so it tries to like force the model to put more significant information into certain bits than others. So that's Matryoshka embeddings. Fair number of models support that. Some models also support binary vector embeddings. This is the thing I think is mind-blowingly cool. So binary vector embeddings is you take every one of the float 32s that might be spit out, and you turn each one into a single bit. And that's just like, is this greater than or equal to 0? And the specific model that I ended up using, and it's out of this German startup called Mixed Bread that nobody's heard of, but I think is doing really, really awesome stuff. Would recommend following what they're doing. They had written this blog post that I stumbled on. Actually, after picking their model, I found this and was like, wait, what? And the thing that's wild about this is that if you look, so this shows the different quantizations of the embeddings. So you can see at the top, it's 4096 bytes down to 128. So you compress the embedding effectively 32 times and retain 96% of the retrieval accuracy, which is wild. I find that mind-blowing. The other thing that is really useful about that is it's also way faster to compute the distances. So you get 45x or something like that speed up, which is cool. So I wrote a blog post called "Binary Vector Embeddings Are So Cool." It's on my blog. There's more information about it, but this topic is just it's neat. The reason why binary vector embeddings are faster is because instead of using cosine similarity, which takes a bunch of computations to compute, you're just using the Hamming distance, which, small refresher, you're just looking at how many bits are different. And that is really, really fast. Computers are exceptionally good at that. Now, I was excited about this, and then a friend who's standing in the back said, how fast is it? And so I got nerd sniped into benchmarking bitwise Hamming distance crates in Rust. Went down a little bit of a rabbit hole on this, was like, okay, it seems like this implementation is a bit better. These times are measured in nanoseconds. And then Alex again said, what about auto-vectorization? Now, what's auto-vectorization? Auto-vectorization is when the Rust compiler, or when any compiler, but in this case, the Rust compiler, adds SIMD instructions for you. And if you don't know what that is, it basically just makes your code go really fast. And the specific thing that this is based on a technique that was inspired by posts from Matt Cladd and Nick Wilcox. But basically, you can write normal Rust code, not specific SIMD instructions, in such a way that the compiler is better able to auto-vectorize it for you and add those SIMD instructions. And so Alex's question was like, okay, if you compare it to something that's meant for auto-vectorization, how does that compare? And the answer was very well. It ranked #1 on this little benchmark that I had put together. And so I actually ended up getting nerd sniped into publishing a crate, which is that the whole contents of that crate is the code that I had up there before. It's extremely short, but it runs really fast. And it doesn't have any platform-specific SIMD instructions. And I wrote a blog post on about this called Unnecessary Optimization in Rust, Hamming Distances, SIMD, and Auto-Vectorization, which starts off with the line that I definitely believe. If you're developing an application and find yourself running a benchmark whose results are measured in nanoseconds, you should probably stop and get back to more important tasks. But here we are. So enough with that aside. We went through using Rust, using binary vector embeddings. Those are two of the things that make this really fast. Another thing is SQLite. I'm not going to go into a ton of detail about this, but you're probably, since everyone reads Hacker News, you're probably aware SQLite is having a bit of a moment. And I think there's a lot of different reasons for it, but the ones that are most relevant here are that your query latency is 0. Your data is right there, and so your queries are just really, really fast. And as we said before, speed buys you kind of nice use cases. One of the things that buys you is that you can do a lot of really cheap SQL queries, because if you're using a lot of you are probably using a database like Postgres, which is great, no qualms with it, but you probably have to write fairly complicated SQL because you're aware that anytime you hit Postgres, you're incurring maybe 100 milliseconds latency, whatever your latency is, you're incurring some latency. And so you kind of need to write your SQL to grab everything you need all at once. And you end up with this like complicated join and getting it back. With SQLite, you can and actually are somewhat encouraged to just like write kind of simple SQL and just like fire off more queries. So a small example of this in my actual code, this is the function that's kind of the most important one called rank items. What it does is it loads up a stream of items to rank. This is it doing the ranking in real time. And I was looking at this code wondering if there's any way I could make it faster. And this is the next segment of the code. And there's this to-do over here that says, to-do, look these up in batches. So I've like loaded a bunch of items, I've scored a bunch, and then I'm like, okay, I want to like reshuffle the top bits for reasons that you can ask me about later. So I need to load up a little more information about those. And I just have this like extremely naive implementation where I just for loop over those items and then make two separate database queries for each item. And I was like, oh, that seems like a kind of obvious area for optimization. And then I looked at the server logs and was like, oh, that represents less than 1 millisecond. Never mind. I'm going to go back. I'm going to go, despite having worked on this like insane benchmark with the nanosecond stuff, which I think actually matters more because I'm doing that like tens of thousands, hundreds of thousands of times. A little bit more. But this was like, okay, I'll come back and optimize this later. Clearly not low-hanging fruit. So this is the kind of an example of you can just make a bunch of SQL queries without having to worry about it. That's pretty nice. I'm also using a project called LightStream, which just runs a sort of side process that watches the write-ahead log for SQLite and then just sends it to an S3 compatible store. It's real cheap, provides disaster recovery, etc. Works pretty nice for this type of project. The last part is the MASH stack, which, so we'll get into what that means. It was also on the slide, so it's not that exciting a reveal. But the two least controversial parts of that are Axum and SQLx. Axum's a really good web framework, part of the Tokyo project. Would recommend it if you're doing anything webby. You're probably already using it, or there's a good chance you're using it. SQLx, kind of the same deal, database driver, would recommend, it's good, use it. The other things that are a little bit more different, I would say, for this stack, is that I decided I wanted to do server-side rendered HTML because browsers are really, really fast at rendering HTML. If you can send them a ton of HTML and they just churn through it, no problem. JavaScript, a little bit, it's a little slower. So I wanted to make it fast, wanted to do server-side rendered HTML, which I will also say a fun part for me is this kind of like new and old mashup of things where it's like, I'm scouring RSS feeds and using like an embedding model, new and old, and then I'm like writing Rust, but doing server-side rendered HTML, also another, that's just like a fun detail for me. So if you want to do server-side HTML, you got a lot of template engines to choose from. These are just a couple of them. And the two main decision points that you have are you either have compile time evaluated templates or you have runtime evaluated templates. And then some of them you have separate template files that look like HTML files or Jinja or something like that, or you have it directly embedded in your Rust code. I initially went with Ascama and was reasonably happy with it, but then found Mod and was like, oh, I like this so much better. So a little like primer on Mod, because I think it's a really neat library that I had not discovered before doing this. So Mod gives you a macro, the HTML macro, and you write HTML in it. You don't have to write like the open and closing tags. You just give it the element type, and then you can give it some classes, etc., attributes, and then the braces are what define the element's scope. I think that's I like that way of writing it. Maybe it's not for everybody, but it feels a little bit like writing something like TSX if you're more familiar with TypeScript web development. And a couple of things that I think are neat about this is that you have this code, your template code is right in your Rust source, and you can splice Rust values right into the template. So if you just put them between parentheses, your Rust values get evaluated in there, as long as they implement the display trait. So that could be numbers, that could be strings, etc. I think that's a nice thing. You also have very simple control flow structures, for, if, else, match. They work like you might expect. And then where it gets a little more interesting is where you have components as functions, which again feels a little more like TypeScript web development. So you can have your header function, your footer function, your page function, and you can mash them up like that. And at runtime, they're really fast because most of the work happens at compile time. One of the details that is getting at why I think the mod plus Axum thing is quite nice is when I was using Axum, there's a very common but annoying pattern where every single page that you have needs some of the same information, even if it's not otherwise relevant, like is the user logged in? Because if the user's logged in, then I want to display some other things like their username in the top right. And that's a really common pattern in like basically every website. And it's a little bit annoying to do with templates because now like every struct that you're passing into the Axum template seems to need that user detail, even if it's not really relevant for that page. I didn't really love that. And then I found this gist from David Peterson, who's the developer of Axum. Someone had asked on Reddit, like, how do I do this? And he had responded with this gist, which I think had a great answer in it. And it's maybe a little bit hard to see, but basically what this is showing is you can have a layout struct that implements Axum's from request parts, which is the way you extract data in Axum handlers from the request. So you can do things like figure out whether the user is logged in based on their cookies or credentials, and then set that on that struct. And then you can also give that same object a render function which takes a template, builds the page around it, and then uses the global context in rendering the header, which I was like, wow, that's way nicer. I'm using that. It's great. This was just like finding it on Reddit and linking this gist, but really, I think it should be more of a common thing. And while I was working on this, I actually stumbled across someone had written up this stack that I didn't actually know was written up as a stack as the mash stack, which they say as simple as potatoes, which I thought was kind of cute. And it's great. I didn't intend to use it, but would actually recommend it. So uses mod for templating, Axum as a web framework, SQLx, HTMX. We haven't talked about the HTMX part, and I'm not going to go in too much detail. I didn't give too much detail about this. That's also kind of having a moment. You've probably heard about it. Would recommend looking at it. It's a really neat minimal framework. But the things that all of this gives you is that loading the feed just from the web infrastructure is really fast. So you can look at, this was the page load for me. So loading the feed the first time took 98 milliseconds. I could probably work that a bit down if I, optimize my queries, maybe get it to 97 milliseconds. And then it's loading a bunch of other JavaScript, but all of those are cached indefinitely because those files never ever change. Those are just the HTMX library and some extensions. And so on subsequent visits, you're loading 4.6 kilobytes of HTML, and that's real fast. So that's one of the reasons why this is so fast and why I think this stack is pretty cool. You can also cheat this a little bit and use the HTMX preload extension, which just does things like when you hover over stuff, it automatically preloads stuff, caches it. And so it makes it feel even more instant because when you actually click, it's already there. So it doesn't even have to fire it off. I'm also using that, so it cheats a little bit. The last part of making something fast, which I didn't mention before, is metrics. I gave a talk a couple years ago about a project I was working on then called Autometrics. Unfortunately, that project it's not really being maintained, but I am using it, and the experience is pretty nice because you get function level metrics. So I can look at how long does the rank items function take to run in practice. It's kind of cool. I'm not sure I'd really recommend it because the project's kind of abandoned, but I wanted to mention it because I gave a talk here a few years ago about it. So the last thing I wanted to touch on, what is not so fast. I talked about what is really fast, and this is what's not so fast. So ranking 1 month of posts, which is somewhere between 150 and 250,000 posts, not that fast, not fast enough for me or for you if you decide to use Scour. So that takes a little over a second. It's not that bad because of the preloading. You may not even notice it, but I don't love it. So that's something that I will be looking into. Another thing that I wanted to add is lexical search. A lot of different LLM related projects will use a combination of vector search and lexical search. And what I found is that it's too slow. And it's too slow in this use case for kind of a specific reason, which if anybody has ideas about, would love to hear. And the specific reason is that normally when you do search, you have one search phrase. And so you just fire off that one query and that's it. For this, you might have a lot of different interests. And in fact, like some users of it have probably like hundreds of interests listed. And for each of those, you need a kind of complicated, compound, full-text searched query, which that ends up being too slow. I might still try to figure out a way to work it in. And then another thing that everybody loves to, everybody's favorite topic to complain about with Rust is compile times. Normally, I don't notice this writing Rust because you run Rust Analyzer, it's super fast. It figures out whether my code is wrong before I need to. However, if you're doing UI development, you kind of want to see the implications of what you've changed. Initially, I think I had it somewhere between like 5 and 7 seconds, which was really felt like ages. There's a post from the Corrode team that was like how to get your compile times down. Did a bunch of their things. Some of those worked better than others, but got it down to about 2.5 seconds. The main thing that actually really helped for me, which you probably want to do, is split your stuff into a lot more crates than you have initially. That one actually made a really big difference, and not really surprised why, but that helped quite a bit. So 2.5 seconds, could be better. We'll try to make it better. And then the last one is SQLite obviously has some scalability limit. So if it hits the front page of Hacker News, might have a bit of a problem. So yeah, I would love for you to try it out, Scour.ing. Feedback is extremely welcome. Post your suggestions and ideas or upvote other people's on feedback.scour.ing. And yeah, that's the talk. Thanks. Questions? Yeah, any questions?
Grab the second.
Oh yeah.
Anyone got questions?
You look like you want to ask a question.
Yeah, it's less a question about how something works and more ideas have you explored, since you mentioned lexical search using something like Tantivy or and such like that. And
yeah, great question. So have I looked at something like Tantivy or however you pronounce it?
I myself have no clue the pronunciation,
okay.
Sorry.
I have looked at it. I haven't actually tried it out. Probably should. One of my hesitations with it is, and this is kind of a minor thing, but I don't know, it's a nice to have with when you develop with SQLite, it's kind of nice that it's just like one file is your database. And so if I'm like mucking around on my development environment and I write some new migration or something, and I want to like back up the database, I literally just copy the file to another one, and then I can just like kill, try it, kill that one, copy it back, and it all works. And so there's something very nice from a just developer experience standpoint of just having everything in one file. It's probably worth looking into whether that would give enough of a performance increase to make it worth it. There is a project that uses SQLite for Tantivy storage, but it says it comes with a pretty big performance hit. So that would kind of defeat the purpose of using it in this case. But yeah, it's definitely something to look into. Thanks. All right. What's my next week going to be sunk into needlessly optimizing? Please tell me, Alex.
We can talk about that over beers, but the prior question there is, are you currently storing all 250,000 posts in your one SQLite file?
Yeah, but I'm not storing the full text, which was, so I'm storing the vector embedding, and I actually am maintaining a full text search index over it, which is like kind of close to the full amount of data for the post, but I'm not storing the post right now. I don't know, I've gone back and forth on that, and there's some reasons to, some reasons not to. One of the things with this project in general is that I'm trying to run it in such a way that it doesn't cost me a lot so that I can make it mostly free and then add some paid features that hopefully people will pay for, but not very expensive ones. And that obviously the economics change if I need to spend a ton of money on it. So I've been trying to do it a bit on the cheap. So that's what I'm doing right now. Yeah.
Question. So you're using SQLite for the backend database. I think it's called LightStream for the wall replication, right? For backing up. They always say don't plan for scale, but like, okay, if you need to then replicate this, right? Like, and you have this single SQLite file, does LightStream, would that actually be like the mechanism for like the replication?
Great question. Yeah, so LightStream doesn't, but the same guy, Ben Johnson, who built LightStream, then was like, okay, that's what everybody asks about. I should add something. And he started working on it, and he was like, actually, you kind of want to do it in a different way. And he built a different thing called LightFS. He now works at Fly.io. They have some stuff about it. That project is not like the most actively maintained. So I actually was using it and then ripped it out because I was like, I think this is actually a bit premature. But LightFS uses some clever and disgusting hacks to scale SQLite. And it's awesome, basically. But it pretends to be the file system underneath SQLite, so it can watch what's changing. But the other thing that it does is, let's say you have a bunch of different servers running your SQLite database, and importantly, a bunch of HTTP servers running your SQLite database. And now you impose this constraint, which normally flies, not always though, of GET requests can't modify things, POST request, patch request, put request can, delete, etc. And then you put a little proxy in front of your actual application. And if it is a GET request, then you just, serve the GET request because you know that it's not going to change anything in the database. And then if it's modifying something, you actually forward it to the leader and then get the request back, but kind of keep the reads hanging until you know that you've caught up with the replication, and then respond. And so that's like a awesome and disgusting way of replicating SQLite. And the thing that I think works probably okay for is stuff that's quite read heavy, which this definitely is, because I basically have like a batch job running to ingest new things. And it's not very common that users are like changing all their settings. And so most of the activity is reading. So it would work for that. Although if I really hit that point, maybe would throw away SQLite. Can't Scour just be eventually consistent? Can't Scour be eventually consistent? Maybe the thing that seems annoying about that is like if you basically like you changing your settings. That's the part that is a little, yeah, maybe. It takes a second for it to resolve. Yeah, that's fair. Maybe I'll just YOLO it and like, just throw it on multiple servers. But yeah, that's sort of the state of play at the moment. Yeah.
Hi.
So for auto vectorization, do you need to set the target CPU to something other than generic, or does generic, like these days, is generic SIMD compatible?
Good question. I'm not sure. I definitely, the generic one. So you don't need to set the target,
Okay.
I believe. Actually, Alex, do you know the answer to that question? I don't.
Needs to know the architecture to be able to use a generic for that architecture. So we'll be able to do anything. Like
Right.
If you're doing Intel, you can use basic Intel instructions.
Basic Intel instructions.
So
Yeah.
there are ones, every Intel chip, every standard Intel CPU has a set of SIMD instructions.
Yeah.
But if you want like AEX 512,
Right.
then it needs to know.
Right. Yeah. No, that's what I
Yeah,
wanted.
so
Yeah, that
so
was it.
your
The
performance
that
is-
generic does have some automatically built in.
Yeah, exactly. So your
that
performance is going to be
targeting
better
Pentium
if you
4
do
these
it for
days.
a really
okay.
specific target. But you can get very good performance without that.
Okay.
And the benchmarks that I had run was just the generic, like not compiled in any
Okay.
specific way.
So yeah, and you haven't benchmarked that
I have not.
with,
So-
with
yeah.
equals native or something.
Once I published the crate, I was
Okay.
like, back to work.
Yeah. All right.
I am done. I blogged about it. It's done. I published it as 1.0 as like first shot, just like 1.0, it's not changing. Someone posted an issue. I'm probably never going to do it. Yeah. Yeah.
All right. I think that's it. I think you've been sufficiently
you.
nerd sniped. Excellent. That's great.
Hey, I'm Cole. I organize Rust East Coast events and help publish these talks with captions. Join our Discord to suggest future talks, attend virtual events, and connect with others. We'd love to have you.